Sets today. In lesson 90, we're learning about sets. A set is a collection of elements. Almost anything can be an element. For example, numbers, ordered pairs, variables, geometric figures. Elements listed in a set are put in braces, which are the funny lines like this. And then we use an ellipse when to show that maybe the list goes back further than one, right? It shows it keeps going in front of it, or it can go behind it. This is whole numbers right here. This is integers. Use set notation to denote the set of even integers. So you have to include the negatives, because integers include negatives, but they have to be even. You include 0. And then at some point you decide, okay, well, these go on forever this way, and they go on forever this way. Don't forget your braces, right? And they did it for us. That's all we're doing today. To indicate an element of a set, we use a symbol that looks like a fancy E. It means is an element of. Remember, elements are the things we're listing. So 3 is part of the integers. But 1/2 is not. Why? Because it's a fraction, and integers are only negatives and positive whole numbers. Example 2, use set notation to indicate whether each number is or is not an element of the rational numbers, which can be shown as a ratio. 2 is, because it could be 2/1, right? So it is and then we put the label rational in braces like that. And they show you in this one right here too, don't they? Letter B is, but C cannot be expressed as a ratio. So we do the value, and then we do a curve D with the line crossing through, and then rational numbers. Graph the elements on a number line. Integers are not the fractions, so you don't do a solid line. You can't include this part, right? These are not an element of. So just show the dots, right? A little different. And then to graph square root of 1, you might want to just type in your calculator, square root 1 equals, and you realize it's 1, right? So you put it right on the 1, and you label it. Now, type in your calculator, if you've got the square root number, 2, it's going to be somewhere between 1 and 2. Smaller, though, than square root of 3. And then, of course, 4 being a perfect square, then we're at 2. So you may not know exactly where to put these, but you know they're between 1 and 2. So you would graph them like that. Sets can also be related to each other. If all of set A is inside of B, it's a subset. Like if we said the even numbers related to integers. Well, even numbers, maybe use a Venn diagram to show this. I'll abbreviate even numbers as E. We can show are within the larger group, that is the integers, right? Since they are all inside of that set, we use the symbol like a sideways tipped over U, meaning is a subset of. So remember, this meant is an element of. This means is a subset of. So like rectangles, yes, they're a shape, but they can be element of a set. They are a subset of quadrilaterals, because every rectangle is contained in that classification of quadrilaterals. Use the subset symbol to show the relations between, we're going to use some really cool symbols today, between the set of natural numbers, which you go like this for, and the set of integers, which looks like the same, but it's drawn like more like a Z. They're just fancy ways to show integers and naturals. Naturals, remember, are like the counting numbers, 1, 2, 3, and so on. So how do those relate with a subset symbol? Are they or aren't they all within integers? I believe they are. Can't think of a counting number that wouldn't also be considered a fancy z, an integer. Let's see how we did. Yep, is a subset of. Here are the rest of the fancy symbols. The natural or counting numbers we did, integers we did. I haven't used this one much, but rational numbers, you make a Q, and then you put these guys on the sides. Real numbers, I don't usually do this part right here. I just do an R, sorry, do that again. An R that's coming off of a rectangle like that. Okay? We talked about subsets inside of diagrams. Intersection, another symbol, is an upside down U, kind of like a curved N. The intersection of A and B is the set of elements that are in both sets. So if I say the intersection between set A and set B, the intersection between, in the Venn diagram would be everything in the middle that overlaps. So they aren't completely a part of each other because you've got this part and this part that are not, but they do have an overlap. For example, rectangles compared to rhombuses, they are not all within one or the other. But the intersection, the overlap between rectangles, I'm just abbreviating, and rhombuses are any shapes that are both the overlap, mutually rectangle and rhombus, and in that blue section that overlaps, that's the squares. We use union and an upward U. That's easy to remember. That means union. Looks like the first letter in the word union. Combining of sets, where you put them together and you count it all. The union of A and B. All the elements in both. Not just the ones they have in common, but including everything in both of them. For example, the union of the set of boys in the room and girls in the room, the union of that would be everyone in the room, right? It's one thing we're looking for and they complement the other half. So if we get this down simpler to just a list where we have 1 through 4 and then the evens between 2 and 8, what is A intersection B? That's just what they have in common. 2 and 4 is the intersection, right? But the union is always a longer list because we include all the numbers. Notice if there is any overlap, 2 and 4 are not written over again. The union just writes the numbers. If there are no elements that are in both, that union would be an empty set, right? Like let's say if there's a set that is 5. Letter C is only the set, the element 5. And then we ask for the union of A and C. We would have to say that is, well, that's an empty set. There's nothing that they have in common. Okay. I love that they give us a table to review everything we just learned. You can use Venn diagrams to show what we just talked about. Let's do B, D, G, and H.